Okay, so for part B, we can basically use part A. So we can say, using our equation from before, so the one that said T equals 10G minus 10A. Now we know that A is 4.1. We just sub that in. So we've got minus 10 times 4.1. Obviously use the exact value in your calculator, but it's fine for now in our working. So plug that all in and we get 57 newtons to 2 sig fig. Okay, so that's example 11. Okay, so if I now move on to example 12, we've got a similar sort of thing. So again, if you want to pause me and if you want to have a go yourselves, then that's fine. Otherwise, I'm going to just carry on. So we've got on the end of a light inextensible string is attached to one end of a light extensible string is attached to a block A of mass 2 kilograms. The block A is held at rest on a smooth fixed plane this time, which is inclined to the horizontal at an angle of 30 degrees. So a lot of this they've done for us, which is nice. So you just read through the rest of it. They've basically done everything apart from the forces, so we need to put all those in. So we've got 2G here, and again, if you want to label up your angles, then that's fine. So that's 30 degrees. We've got here 5G. That tension is going to be the same as this tension, so I'm going to call them both T. I've got a reaction force. This time it's on a smooth plane, so we've got no friction to worry about, which is nice. And then that one is going that way, and this one is going this way. That's a terrible arrow, I do apologise. Okay, so part A, show the acceleration of the block B is 4/7 g. So what we're going to do is very, very similar to last time, except this time we don't have to resolve perpendicular because we're not trying to find out what the friction is. So we can just go straight ahead and resolve parallel. Okay, so I'm going to resolve parallel at A. Okay, so I've got, I'm going to go in the direction of motion. So I've got T minus 2G sine 30 degrees is equal to, so we're going to use mass times acceleration to A. So because we kind of done this sort of question before, I'm going to just add an extra cheeky step for later on. So I'm going to put T as the subject, so I've got T is equal to, so I've got 2A, and then I know that sine 30 is a half, so I've got just plus G. And then I'm going to resolve vertically at B. This is, as you can see, very, very similar to the last example. So I've got 5G minus T is equal to 5A. Okay, and then again, I can just substitute, so this equation into this equation. So I'm just going to label what I'm doing every single step so it's nice and clear. So substitute 1 into 2, just so I know what I'm doing, and anyone looking at my work knows what I'm doing. So I therefore got 5G minus 2A plus G, don't forget brackets, equals 5A. So I'm just going to collect my terms. So I've got my minus 2, I'm going to put on the other side. So I've got 5G minus G is going to give me 4G. And then 5A plus 2A gives me 7A. It's all coming together. So I've got A equals 4/7 G, like they asked me to show. Okay. And then again, very, very similar to what we did in the other example. They want us to find the tension. I'm going to do it over here where I've got the space. So I'm going to just use this equation 1 really. So I've got T equals 2A plus G. So I'm going to substitute in. I know the acceleration is 4/7 G plus G. So I've got 8/7G, so that gives me 15/7G, and I'll pop that into my calculator, and I end up with 21 newtons to 2 sig fig. Okay, and then I'm pretty sure I can squeeze in part B here, and then we'll go on to part C on another slide. So state how you've used the fact that the string is inextensible in your calculations. So I'd say the string is inextensible. Oops, if I can write. Inextensible. Apologies, my handwriting's a bit messy on the tablet. So we would say the acceleration is the same for A and B. Okay. That's an and sign, by the way, sorry. Okay, cool. Right, so if we go on to part C. Now, part C, if you just read it, it says, calculate the magnitude of the force exerted on the pulley by the string. So the force exerted on the pulley by the string is basically the resultant of the two tensions. So the magnitudes are the same because they're both going to be 15 over 7g or 21 newtons. So the line of the resultant force, or the line of action of the resultant force, is basically going to bisect the two tension lines. Okay, so what I mean by that is something a little bit like this. So we've got the two tension forces here. So we know that this is going to be 15 over 7g. I'm going to leave it exact just so it's super clear for everyone. So 15 over 7g. And they want us to find this line here. Now, what we can do, so if I use a bit of alternate angles, I can say, right, that's going to be 30 degrees here. Okay, and then because I know that that's going directly through the middle of these two forces because they're the same magnitude. Let's call this theta. And this theta. And then is everyone happy that this is a right angle here? Yeah. So if we use a little bit of geometry, we can say that we've got 90 degrees minus 30 degrees, nothing too strenuous, equals 60 degrees. So we know that 2 theta is 60 degrees. So theta is also 30. Coincidentally, this doesn't always plan out this way, okay? So that's 30 degrees and that's 30 degrees. Now, what we can do is we can sort of do like top to tail, as it were. So if we're trying to find the resultant force, we can say, right, we've got this force going like that. And then we can sort of attach this force on. So I'm just going to literally draw that force in like that. Okay. So we've got tension here, okay, like that. So we want to find this line here. Now, the easiest way to do that is if we turn this into a right angled triangle like that. This is actually an isosceles triangle. So because we've got the tension there and the magnitude is the same as the magnitude of the tension here, if we find out what this part is, so this bit here, then we can just double it. Yeah. So I know that that is T. And I've got my angle theta here, which we found out was cos. So I could say that I've got this line here is going to be T cos theta. So because I've got basically an isosceles triangle, I can just say that R is equal to 2T cos theta. Does that make sense? If it doesn't make sense, do email me and I'll try and explain it in a slightly different way. So if we plug in all our bits and bobs, I've got 2 times 15 over 7g. I'm going to leave it in its exact form, or as exact as possible, just for the time being. Times by, so cos of 30, we find out that angle was. So if we pop that all together, I've got 2 times 15 over 7g. Times by cos 30 degrees, which is going to be root 3 over 2. And then we just put that all on our calculator, although you can probably see that that cancels out with that. So it's actually going to be 15 root 3 over 7. So just do that a little bit on paper without a calculator, but we will put that in a calculator so we can see what we're doing. So we end up with 36 newtons to 2 significant figures. Okay, hopefully that makes sense to you. If not, do just pop me an email and I'll try and explain it in a slightly different way, or you can have a look in the textbook, but it does it very similar to how I've just done it. Okay, all right, thanks guys. I'll do chapter 8 hopefully tomorrow, or if not then next week. All right.